हेलो एवरीवन, कैसे हैं आप लोग। चलें जी, आज हम इनपुट आउटपुट डिवाइसेस शुरू करते हैं और रिमेंबर दिस इज ओ लेवल। वालेकुम अस्सलाम सलमान। Remember this is O level, so we don't have to get indulged into details. All we have to just scratch the surface. We have to learn the principles of operations. सही है ना, मोटी मोटी चीज़ है. We don't have to get indulged into deep down details. All right, so we need to know that how something works apparently, and a little about the functionality, not too much of detail. All right, तो पहले हम शुरू करते हैं इनपुट डिवाइसेस से. एक एक डिवाइस लेते हैं, डिस्कस करते हैं व्हाट इज इनपुट device, and then what are the devices that we have to cover. That is how we will go further. All right, so let us start. This is the last topic, and then we will start yearly past papers. I think for online students, ethics remain. So we will see in tomorrow's class, I mean the Friday class, that what is left for online students, and then we will start. Okay, so let us start. Input devices first. So first let's discuss that what your syllabus says, and then we go further. देखिए, आपका जो syllabus है, it is 1.3.3. It says that describe the principles of operation, how each device works of these input devices: 2D, 3D scanners, barcode readers, QR code readers, digital cameras, keyboards, mouse, touch screens, interactive whiteboards, and microphones. Describe how these principles are applied to real-life scenarios for scanning of passports at airports, barcode readers, supermarket checkouts, and all. Walaikum assalam, Umar. Now, then we will discuss about sensors as well. So this area, how these principles are applied to real-life scenarios, or this area that how sensors are used in real-life scenarios, we will complete these 2 points, which are the applications, with the help of past paper questions. As far as describe the principles of operations and describe how these describe the range of sensors, we will first cover it in theory. All right. So let us start. Walaikum salam to YouTube. Okay. Now, what is an input device? What is an input device? All right, what is an input device? Input devices are the peripherals used to provide and control signals to a computer. Input devices allow us to enter data for processing. So let me put it in short words. Peripheral devices to provide data to computer. Devices to provide control signals to computer. Devices allow us to enter raw data for processing. There are many devices which we have to cover today for our syllabus, and there are benefits and drawbacks attached to those. So devices in syllabus that we have to cover: mouse, trackball, keyboard, then we have microphone. Sometimes we do have concept keyboards as well. Then we have microphone, digital camera, we have 2D scanners, we have 3D scanners, then we have interactive whiteboards, touch screens, barcode readers, then we have QR codes, quick response stores, QR code readers, and then we have, I think that's it. So these are the devices. So let us start with the one and the only mouse. Mouse is a device. I would say that this device is basically very much like computer itself. It has got its own processor, which is called DSP. Uh, what's on here? Hold on, hold on. Shahir. Okay. Rija, this is additional class. We will continue in next class. So yeah, whatever that is left in the previous class will be continued in the next. This is the difference class. So what is mouse? A mouse is an input device or pointing device that allows you to control the coordinates and movement of on-screen cursor pointer by simply moving the mouse across a flat surface, which is the flat surface is any flat surface और हमारे पास mouse के जो mats होते हैं with your hand. All right, so mouse is an input device that allows you to control the coordinates and movement of the on-screen cursor, which is sometimes called pointer. Because of this pointer, we also call it pointing device. Pointer by simply moving the mouse across a flat surface. All right. So items can be selected on the screen. Items are icons. Items can be selected or moved using the left mouse button. There are two, while the right mouse button usually displays additional menus, which is context sensitive menus. Most mouse are now optical. There are optical mouses and there were ball mouses, ball underneath, analog mouses. Analog mouses were those which had a ball underneath them. So most mouse are now optical, which means they are using laser to detect and track movement across the surface. Mouse can be wired or wireless. All right. Typical applications of mouse. Typical applications of mouse are basically it is used in everyday life. Computing. What is computing? The use of computer for anything. So used in everyday life, computing to control the pointer. In graphical user interfaces. What are the benefits? Benefits are simple and easy to use. An efficient way to navigate. All right. Drawbacks. There are drawbacks. Drawbacks of mouse are require a flat surface. Although we don't consider it as a drawback, but yes, this is a drawback. It requires a flat surface. Second one is it requires space. Yes, and there are basically human injuries like uh, RSI. Repetitive strain injury. This is RSI. All right. So it is an injury to part our hand, skeleton, and there are muscles and nerves that may get hurt with the use of mouse if we use it a lot. Like for example in gaming. All right. So nervous system can be damaged sometimes. Can be hurt at least. So there are ergonomical mouses which we mostly use, but we are not going to get indulged in that. All right. So, what are the principles of operation for a mouse? So, mouse is having a laser underneath it, and that laser is when reflect back from the surface is read by a camera. The camera is reading the laser and creating an image of it, and then comparing the difference between the previous image and current image, and then computing the whole difference from the previous point to this point, and then sending that difference after calculation to the computer. And computer is doing only one thing, it is actually showing the pointer on the screen. So all of the calculation that is basically happening is inside the mouse. So it has got a DSP, digital signal processor, it has got a camera, it has got a scanner of the camera, it has got a laser unit which reflects a laser from the surface. So laser reflects from the surface, get back. Camera takes a picture, sends to DSP. DSP then uh, processes and finds the difference between the previous image and the current images, and then determines the coordinates, newer coordinates, and those calculated coordinates are then sent to the computer, and computer is basically showing the mouse pointer at a new location. Now, after mouse, we have got trackball. Trackball is, you might say that trackball is reversed mouse. Means, let's say, if we have got a mouse, something along, I'm not good at drawing, but sort of something. It's a mouse, but it does not have a ball underneath it, rather it has a ball on top of it. This is the ball. All right. So it does not require space, rather it just requires you to place your hand on top of this thing and move this ball on top. All right, so you place your hand on this thing and move this ball with your finger, and that is what the trackball is. I call it inverse mouse. In our common mouse, what basically happens, the unit which feels the surface change is underneath, either a laser or a ball. But in trackball, if you would basically Google it, you would know. So, सर याद तो हो हमें वो ही रखना होगा ना जो आपने लिखा है स्क्रीन पर. जी हाँ, वही रखना होगा याद, वही याद रखना होगा जो हमने स्क्रीन पर लिखा. So what is trackball? So a trackball is an input device used to control a pointer or cursor. An input device to control on screen cursor or pointer. All right. Unlike mouse, the device is stationary. All right. while the user moves the ball within its socket. All right, that is how it works. Trackballs can be standalone devices or combined into the keyboard or control panel. I used to have a laptop. On the right of it, there was a big ball. Although that ball was not small enough to move with the finger. Rather, I used to put my palm on top of it to move it. But such type of devices are now mostly obsolete because they are taken over with touch screens and all. So they can be standalone or combined into the keyboard or control um, or keyboard or the control panel, whatever, if the device is non-computer device sort of. Now, typical uses for trackball. Some people prefer using trackball over the mouse as they believe it gives them a finer degree of control over the pointer. Yes, people like engineers, people like those professionals who like to work with the precision, and, or they are using 3D maps or something sort of. So in that case, people prefer to use trackballs. But these are specialized applications. We don't have to worry about those. These are specialized applications, and the devices which are made for these applications are actually having these trackballs on top of it. All right. Sir, it is similar, like mostly in laptops, there are circular button between the keys G and H. That is something else. That is something else. That is a knob. वो कुछ और है जुनेर, वो ये नहीं है, वो ट्रैक बॉल नहीं है. ट्रैक बॉल इज अ बॉल. वो कोई और चीज होती है, वो आईबीएम के पीसीस पे बहुत ज्यादा होती थी. उसको हम क्या कहते थे मुझे याद नहीं आ रहा अभी. So some people prefer using trackball over a mouse as they believe it gives them a finer degree of control over the pointer. They are also handy for people with limited hand motion. So if they are handicapped, God forbid, then they also help them. All right. So all you need is a finger to move that ball. So what are the typical applications? So applications are computer-aided design, engineering works, where we actually CAD, we call it CAD, computer aided design. So whenever we use computer to design a map or architecture or anything, this is the control. Where space is limited, we don't have enough space like we do need a mouse. We need to put mouse over the mouse pad. Mouse pad requires 12 by 12 inches of space. If we don't have a space to move, it is good idea to use trackball, and it is a good help for disabled people. So we might have people who are disabled, they cannot move a lot, or they are unable to move their hand a lot. So it would be a good idea that such people will use, with limited motor skills, will use tracker ball. Okay. So now what are the benefits? Benefits might be neat, little desk space, finer control rather, can be integrated within the keyboard. Things like that. There are drawbacks, obviously. So the first drawback is, and first and the only, you might need some time to get used to. All right, so these are the things about trackable or trackball. Sometimes people call it tracker, sometimes they are calling it track, but your syllabus says it is trackball. Now, Sanya, will you please tell in the group that I have approved Ali Asif as well? There are no further requests. Sanya, please tell them. All right. Now, next one is keyboard. Now, what is a keyboard? A keyboard is an input device that allows the entry of data and commands by simply pressing down keys on the keyboard. Keyboards are commonplace input devices often used alongside a mouse. They can be wired or wireless. So, input devices that allow the entry of data and commands by simply pressing keys over the keyboard. All right, keyboards are very common. Commonplace input devices often used alongside mouse. They can be wired or wireless. All right, they can be wired or wireless. All right. Now, what are the typical applications? Oh, these are many. What could be those? There are so many applications in everything they are being used. Even at ATM, you might see a keyboard that is having only numerical keys. It is over your cell phone. It is over every device that we have nowadays, which is doing some sort of calculation. All right. So wireless keyboards and without wire keyboards are the same. Yes, they are the same. Wireless means without wire, Peter. So So what are the typical application? There is just application for this thing in everything. So in everyday life, they are used in every computer application in business or at home, from gaming to banking, isn't it? All right, these are the typical applications. You name it, everywhere they are being used. So what are the benefits? They are very much intuitive. They are intuitive, easy to use, potentially fast way to enter data. Isn't it? They are very handy, very handy. Even when computer was not common, people used to have these keyboards with typewriters and all. So keyboards are very well taken by humans. They are very good, very good. So when there are benefits, there are drawbacks. If someone is not trained, but they are not good with keyboard like me, what is the first intuitive? Intuitive. Okay. Intuitive. Intuitive. Now, so it becomes very hard. Intuitive means that you look at it and you know how to use it. That is intuition. Means you know it by yourself. You look at it, you get it. This is so much easy to use this typical keyboard, isn't it? So drawbacks are it becomes slow, use if the person is not trained to enter data. And spell mistakes. You see, we have to find errors, drawbacks. So mistakes can be there if not careful, and there might be then injury. Those people who look at the keyboard when they are typing, they might have neck strain injury, and those who are typing might have their wrist strain injury. All right, so human injury is also possible in neck and wrist. All right, neck strain injury and wrist strain injury. Now, What is the principle of operation? It completes a circuit when we press a key. It completes a circuit, and then that press is being read by the DSP, digital signal processor, over the keyboard. It matches the flow of current with the list, and it realizes that what is the key that is being pressed, and then it's transferred that key's ASCII code or the control code to the operating system. So when you press a key, it completes a circuit. That circuit is then read by the on-board DSP, digital signal processor, that is the microprocessor of the keyboard. It then matches that input with a list that it already has to know that which key is pressed, and then sends the control signal for that particular key, for example, the ASCII code, to the operating system, so that operating system knows what is the key that is being pressed. So I believe that let's write the principles of operations for the devices so that you have an idea. So let's write for the common devices, like for mouse. Let's write principles of operations. Laser is beamed toward the surface. It reflects back to the camera. Camera takes the image. Image is transferred to the digital signal processor. DSP determines the change in coordinates calculated coordinates are transferred to the operating system. All right. So these are the steps. Operation steps. Mouse operation steps. Laser is beamed towards the surface. It reflects back to the camera. Camera takes the image. Image is transferred to the digital signal processor. DSP determines the change in coordinates. Calculated coordinates are transferred to the operating system, and then operating system shows the pointer at the new location. That's it. This is what is the principle of operation. I doubt there would be any thing related to this in exam, but if there will be any, then you would have to write the operations step. So similarly, we might have to actually put few lines for operations of keyboard. User presses a key, it completes a circuit. Current flows to the digital signal processor, DSP. DSP matches the data with a preset list. Pressed key is determined. Control signal or ASCII value of the pressed key is sent to the operating system. Operating system shows or does according to the key pressed. It means that if it is a control key, let's say control S, it saves the document. If it is just A, then it shows the A over the screen. All right. So these are the keyboard operations. So user presses a key, it completes a circuit, current flows to the digital signal processor, DSP matches the data with the preset list, pressed key is determined, control signal or ASCII value related to the pressed key is sent to the operating system. Operating system shows or does according to the key pressed. So that is how it works. Now, the next one, it is basically, there is something called concept keyboard, but that concept keyboard is not part of our syllabus. So let me just tell you what are concept keyboard. Few books basically tell about the concept keyboards. So concept keyboard is an input device similar to traditional keyboard, but each key is identified by an image. You might have seen concept keyboards for other languages. All right, the images are chosen to symbolize commands, option keys, each represent. In a fast food restaurant, you might have seen in KFC or in basically McDonald's that they have a keyboard which is showing basically the images of the menu items rather than Shamir camera. All right, so basically those keyboards which you might have seen at KFC and what do we say, McDonald's are basically the concept keyboard. So they are not related to the keys which are over the keyboard. Rather, they are related to the work which is being done using those keyboards, like menus, menu options. So KFC keys would have those burgers and chickens made on top of it. All right. So the images are chosen to symbolizes the options each keyboard represented. In fast food restaurant, let's say the concept keyboard belong to the cashier. He may use images to represent each type of meal available to purchase, okay? Or each size of the drink that we can choose. All right. So these are concept keyboards. So we are not going to study concept keyboards anymore. So let's start with microphone. So microphone is something really good. Let's make one. So we do have microphones in our life. They are very common, very good devices. Actually, this is the microphone because of which I am able to reach you people out there. This is one of the microphone that I realize, isn't it? And let's say it has a handle as well. So bring it up, and there is always a wire. So a microphone is something which is as tiny as a hole on our cell phone side, and it might be as big as this one, the desk microphone, which I have just drawn over here. So what is a microphone? So microphone are input devices that take analog. Analog means something which is natural sound, wave and converts them to electric signals. All right. These electric signals then are converted by the uh, computer for its use. Microphones play an important role in speech recognition. They play an important role in speech recognition. As you might have come across with Siri or Alexa or Google Assistant. All right. This is basically something which is getting very popular nowadays. So what are the typical uses? Oh my God, there are so many. Number one, mobile phones. Mobile phone without a mic is nothing. Tablets, laptops. I am actually reaching out to you using a laptop. All right. We are doing video conferencing. We are using Zoom. Or sometimes we use WhatsApp to call someone, which is called voice over IP. All right. So voice over IP. This is something using IP networks to make calls. All right. voice recognition system. All right, so these are a few of the uses. What are the benefits? There are benefits. Allow disabled user to give instructions to a computer. Yes. All right. Second one is enable the speech recognition software. All right. Third one allows voice calls. Over digital devices. Okay, like in voice over IP thing. Now I want to tell you one of the drawback first, then operation. Speech recognition accuracy can sometimes be a hit and miss. This is the only drawback that I could see. Because of the accent, because of something else, because of some disturbance. But with the use of artificial intelligence, now speech recognition is, Sir Siri is an example of speech recognition. Yes, Manal, because when you talk to it, it talks back. So if it does not understand you, how would it make sense? All right. So I need to tell you one thing. You see, we humans are basically producing sound which is analog. Analog is basically natural. Natural is continuous, which never end. It travels. Energy shapes are changed, but energy does not die out. Continuous means something along these lines. Whereas computer is digital, means it is in binary form, means it is discrete, means computer cannot be continuous this way. So what computer does, it rather takes samples, reads from here, then here, then here, then here, then here, then here, then here. So it might be 0, 1, 0, 0. It might be 0, 0, 1, 0. It might be 0, 0, 0, 1. It might be 1, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1. So when system reads it in binary form. So it is not actually reading it as we read a sound continuously. It is reading it like this, then like this, then like this, then like this. So whatever the data in between is gone. Either you take so many different discrete samples with less time in between, or you lose it. So that is how computer works. So the device that helps computer to turn analog things into digital is called analog to digital converter, or ADC. And in this case, our ADC is sound card. We have got sound card in our cell phones. We have got sound cards in our digital machine, no matter it is laptop, it is desktop, it is a tab, whatever. They all have this. So this is basically, so analog is always, as I said, converts them to electric signals. So analog is always electric signal. Okay, so electric signals are produced. So analog are basically electrical signals, which are natural thing. Okay, and then these electrical signals are being converted to the discrete form. Now, what basically happens when you produce sound? Sound basically makes a change in the environment by having these particles vibrate. This, when you produce the sound, the particles in the air, they start vibration. They go, they hit the diaphragm. Diaphragm, DIAPHRAM. All right, DIAPHRA. Hold on for a second. So diaphragm is having, on the top there is a magnet. On the magnet there is a coil. All right. So this diaphragm is connected to this particular coil. With the help of this coil, the electric current is produced then. So this thing here is basically the microphone. All right. So this is diaphragm. This is magnet. This is coil. So when particles hit the diaphragm, this is the sound. So when the sound is produced, it brings the change in the particle. Those particles enter the microphone. Microphone has a diaphragm on the top. The diaphragm actually hits against the coil and the magnet that produces electrical current. That current then is received by the sound card. Sound card is basically ADC, analog to digital converter. Then sound card basically converts, like I told you, that it reads the electrical current which is analog, it converts that to the binary form and then it saves it. That is how the whole thing works. So this is, let us write it, the operation. sound is produced, it brings change in air particles hit the diaphragm on the top of mic. Under diaphragm, there is a coil and magnet continuous vibrations over the diaphragm produce electrical current because of magnet and coil. Electric current reaches to ADC, which is sound card, and gets converted to binary form. So this conversion is called digitization. All right, so this conversion is called digitization. So that is how the operation of mic works, microphone. All right, that is how it works. Now, digital camera. This is something we all know of. Digital cameras are input devices that capture images digital. Direct digital images are being captured. All right. So these are basically input devices that capture images digital. All right. So these capture images digital. Now, digital cameras use an image sensor chip to capture the image. They use image sensor chip. Chip is basically like something like IC, integrated circuit. It's a little board which is having all the sensors on top of it. To capture images. traditional old cameras, we used to had a film used by traditional cameras. But nowadays there is a sensor chip. Bigger the sensor, better the image sort of thing. Alright, so sensor chip has got sensor. More the sensors, better the. Every single sensor is related to one pixel on the camera. That is how it works. So digital cameras use an image sensor chip to capture the image rather than the film used by traditional cameras, because this is digital camera, it captures direct into the digital form. So we don't need digitizer. It just happens inside the camera itself by the sensors. The image recorded on digital camera is stored on memory card. Images recorded on the memory cards. All right. And you might have additional memory attached to it, or you can put a wire with it, connect it to the computer and download it. Yes, Ali Raza, it will be. It will be. Now, digital cameras feature an LCD screen as well. They have LCD screen as well, which allows you to preview and review images. All right. And there are menus, operating system, everything is in there. All right, so it is similar camera as it is in your cell phone, but the lens is bigger because it is a dedicated camera. It is not a cell phone. So the digital camera are input devices that capture images and sometimes videos as well. They capture images digital. Digital cameras use an image sensor chip, to capture the image rather than the film used by the traditional camera. So it is using it. Thirdly, the image recorded on digital cameras is stored on memory cards, and you can attach more memory to it as well. Number four, digital camera features an LCD screen which allows you to preview and review your images. And you might have several menu options as well. What are the typical uses? Applications. Images are used in digital photography, professional photography, sometimes using DSLRs. DSLRs are those cameras now are popular with you people, which means digital single lens reflex. All right, so we can photograph. Yes, Ali Raza, we can photograph for newspapers, for wildlife, for landscape, for portraits. So DSLR is basically something quite popular with you people nowadays. So DSLR are digital single lens reflex cameras, which is not part of our syllabus. So just move on. And sometimes if we are not professional, but we like to do it, so that is called amateur photography. So as Ali Raza Ali Merchant said that we can photograph for newspapers, for wildlife, for landscape, for portrait, or at home, whatever. Now there are speed cameras as well. These are also digital. All right, and there might be other things. Now, what are the benefits Benefits are images can be reviewed immediately, as those people which used to have this old style camera with a film, if they have taken an image, that image, if it is not taken well, it is gone. It is wasted. So you have to take another image. Nowadays, if we are reviewing it and we don't like it, we just delete it and we take another one. So this is a great benefit. Images can be reviewed immediately. Via the screen, images can be copied or edited. Images can be automatically shared. You can share them with anyone you like because it is in the digital form. Now, what are the drawbacks? Drawbacks of digital cameras include a good camera is needed to match the quality of traditional film. We need sometimes the performance is not satisfactory because digital cameras require a lot more help. They are expensive. If you want a good quality camera, you need more expensive camera. If you require a better image, you might need a bigger sensor to have more light in it. So a good camera is needed to match the quality of traditional film. I feel like to match it with something that we have already seen. We want to make it as good as that thing. So large capacity memory cards are needed sometimes. Large memory is required for better quality images. Well, these are not real drawbacks, but yes, if you have shortage of finances, then yes, they may become very expensive lens. Yes, they are expensive. They are expensive. Expensive accessories. So this is what the digital camera is. Then we have 2D, 3D scanners, whiteboards, touch screens, and there are so many things. So let's keep it for much of it is covered. Let's cover 2D camera and 3D camera, and whatever is left after 12, we will keep it for the next class. Now, 2D scanners. 2D scanners are those desk scanners that you might have seen, something along these lines. So you put paper over here. This is the flat surface where you put the paper, and this is the white paper already attached on the back to close it, and that is how it works. So this is 2D scanner. All right, your photostat machines or Xerox machines are already 2D scanners. So what is a 2D scanner? So a 2D scanner perform the task to turn a 2D document or image into digital. To a digital file or form. All right, so that you can save it. So this is basically called the flatbed one, flatbed. All right, there are two forms. That is flatbed and handheld. And handheld. And some printers have these inbuilt 2D scanners. The biggest example is that photostat machine, or what do we call it? Xerox machine. All right. The functionality of 2D scanners is enhanced with the combined OCR and OMR software. Its efficiency is enhanced using OMR, optical mark recognition, and OCR, optical character recognition. Means you can turn a written or printed text into editable form. And OMR is the one that actually reads your multiple choice questions choices. All right. We are not going to discuss those in greater detail, but OMR is the software that reads where have you encircled the option, and OCR is turning whatever the type text into the editable form so that you can edit it easily. All right. Okay. And then what are the typical uses? Converting a hard copy document into an electronic digital form. All right. Digital form can be shared then. All right, that is an application. And there are other applications like reading passport. This is your syllabus requires you to know reading passports at airports. All right, handheld scanners can be used. So what are the benefits? Benefits of 2D scanners, they can produce high quality digital copies of the produce high quality high quality digital copies. We all know about it. Digital copies can be sent electronically. This is another benefit. Shared electronically. It can be edited. Let's edit. And that's it. Now, what are the drawbacks? There are drawbacks. Drawbacks of 2D scanner are not just the storage. Scanned documents use a lot of storage. So that's about it for today. Now we have got 3D scanner and interactive whiteboard and then touch screens and then we have got types of touch screens, then we have barcode readers and QR code readers. They are all remaining. We will discuss those in the next class. Sir, आपने संडे को P1 की ऑनलाइन क्लास कंडक्ट की थी? नहीं, I could not Jibril. I had connectivity issues, so I could not do that.